Hi, this is another Antminer repair video, and tonight we're going to look at a zero ASIC problem on this T17 hashboard. If you like what the content is and it helps you, please subscribe to this channel, and you'll get notified when I do some more fixes on some more of my cards. In addition, if you want to help with defray some of the costs for the video equipment I have, there is a Bitcoin address to donate or a PayPal address, and I would appreciate any donations if you find this stuff useful. Okay, so this card is coming up zero ASIC in the testing machine, and this is particularly difficult because I don't know if you can tell, but you see a couple of these heat sinks are a little bit crooked on here. I've been on this card before, and I've probably done some things, and I think if I remember this card right, I really should label it right here. If I probably made some changes to this card or checked it out. The problem with zero ASIC is most of the time it's either chip 1 or 2 or 30 or 29. And I think I've pulled these off and checked it. So what I did during the testing cycle is I started testing voltages. Because I shouldn't have, I think I looked at these, and tonight we're going to take these off and look at them again, just in case I introduced a solder ball or something. But I went ahead and I started measuring voltages, and the way I did that was actually on the back of the card. And let me see if I can get my handy dandy microscope here and show you kind of where, if I can show this on here. Let me turn this on. So you can kind of see that there, hopefully, in here. Great. So let me see if I can show you those ports in there anyway. So these are the test ports in between the two chips. Yeah, right there. If I can focus them there. And they're labeled. Better off labeling. Let me move this down. If you look in between, let me find one. Where are you guys? Oh, right there. Okay, so let me focus this in. Supposed to be around there. Hang on. Sometimes it's kind of hard to find on this microscope, especially when you're recording a video. Test ports. Right there. Hopefully you can see that barely. So they're a little backwards because it's on video, but there's a clock CLK tester. CI is, I think, something N. RO is the return thing that goes backwards through the chips. And then there's a reset and a BI, which is another data feed. So I put a ground against the chips, and I put a pin into one of these dudes, and I can measure the voltage when it's looking for the chip. So I'm going to shut that off for a second. And so what I found is on chip, let me see, on chip, I was following the clock signal through here. The clock signal should travel up and down and up and down and up and down through here. It's following the clock signal, which involves testing the ground and the clock signal here, then moving the same test port, testing the ground and the clock signal here, and just kind of marching through the cards. And I noticed that the clock signal is fine here. It's fine going into this chip, but it never comes out of this chip, and thus it doesn't come out of this chip. So there's a dead clock signal on these two boards. It should read either 0.9 volts or 0.8 volts or 1.7, depending on which sweep of the card is going on. So I'm a little bit concerned about this. So I want to look at this tonight. And then because of the zero ASIC, it could be that these are causing the zero ASIC, that just nothing's getting through. But I have to look what's under this card. But I will look at these again. So we'll examine these two chips and these two chips. And I'll take those off right now. So I already marked these two so I wouldn't forget what it is. I'm going to turn on my hot air gun and find my this soldering iron has been well used. It kind of has to warm up a little bit. Yeah, come on, baby. There you go. Okay, so I have this set for about 350 degrees. I'm gonna run it on these. We're gonna take these off, then I'll take these two off, and you can't see it because I've got this card down a little bit, but I'll take these two off. So off they come. It'll just take a second. So I just wait till these things want to come off. I don't like the zero ASIC failure when I think these are okay. It's very difficult to find. I mean, it could be any chip in here that just has tremendous problems. I know that can happen because I've replaced a chip and it didn't quite set and it just caused zero ASIC, and it's like, well, that's good. The other thing that could happen with zero ASIC is there's firmware on this chip, on this board. Each board has its own firmware itself. And let me get that off. And if that's bad in the machine, if the programmable IC can't operate, it controls the power to everything. If it's hosed, it won't start up anything. So there's a PIC kit. Zeus sells a thing that you can just hook up and copy it from a good card and put it on a bad card. I commonly have to do that after I've messed with chips, but let's see what we have here. Okay, that guy's ready. So we'll take a look in here and see if there's anything unusual. Maybe I see something down there. And then what I want to do is turn this card around. We're going to go ahead and take off the two beginning on each side. So we'll examine those. Let me show you what I'm doing here. It's kind of hard to see when I get out of the video. These big guys take a while to warm up. Just be patient. Don't rip them off the chip. I did a video a couple of days ago where I found some bad resistances. I'm going to queue up and I'm probably going to replace the chips on that, but wasn't quite ready to do that tonight. So I thought we might just look at some more boards. I have about 6 boards out there that don't run, and I'm looking for an easy win before I have to do the chip replacement because some of them don't like chips. So we'll just take these off and then we'll have a look at what it looks like. That guy's ready? Good. Come move this guy up and we'll pull these guys off. I tested the voltages coming out from these and they all checked out to be fine. So I'm really not at all sure why we're getting zero ASICs. If I have to, I'll just take everything off the board and test all resistances, but try to do my homework before we do this. I'm wondering if we have a bad card here. It's hard to tell. We'll check the resistances too. That guy's ready to come off. Yeah, I've been here before probably, but see the solder's missing off the top of that chip. Okay, there we go. All right, good deal. Put this guy up. I'm going to switch video sources now so you can, I guess we'll use the microscope. So hang on a second. Goes. All righty. Where are you? There's the first chip. All right, let me start that up. And get a focus on this guy a little bit. So there is chip. This would be chip number 30. So I can also see him. It looks like to me, just in general, that we're pretty clean. Those guys look good. I don't see anything really just sticking out. I'm going to have to go back on alcohol on him and look at him. Then the next chip is, if I can get this. Let's see, we have a little bit of flux covering up that guy. Let me see if I can find him. Just a sec, I gotta find him. Okay, flux covering that guy up. So let's take him out. looks generally okay. The flux just needs to be removed. I will check the resistors too. I'll go back and check the resistors. But like I said, they have, it's kind of hard on my camera sideways from my orientation. So that looks pretty good too. So let me fully, yeah, that's it. So I don't see any huge solder balls. There's a resistor. See if we can follow along here. There's 3 resistors there. Those are all those 33 ohm resistors. Those look okay. This is kind of interesting right here though. What's this? This looks weird. Let me see where I'm pointing. See, we have 2 resistors, nothing here. I think that's normal, although that guy looks toasted. He may not be. So that's kind of interesting. I'll keep an eye on him. I'm not sure he's a problem though. So let's keep following back up to chip 30. There's chip 30's resistor there, the one going out RO, and then we've got the 3 coming in and some capacitors. Looks like I've done a few things with flux up here, some old stuff. The older style I did less cleaning, so yeah. So getting used to the new orientation of my camera here. So, all right. So that looks good. I'm going to shift over to the middle chips where let me find them. So we're going to follow this dude down here. It's just opposite of what I want to go. Sorry, I need to orient that better. There he is. So there's one of them. Okay. Looks like to me he's okay. I don't see any solder balls in there. So let's follow through and look at the next line. You see a tiny piece of solder right over here. I don't think that could be enough to cause a problem. I think I had to take that off the board though. So let's see if I can get him off. He's pretty stuck to the board. I'm not too concerned about that little piece of solder. So let's keep following on. Got some resistors right here. So there's the next chip. It looks pretty good. And then leaving the next chip. These guys, there looks like something might be wrong there. There's something funny going on. The top of the screen. Let me see if I can get down there. Right there. Something's happening there. This is the power coming in. It's not a power that's regularly checked for resistance, but you see those 2 pins really close. So we need to take a closer look at that. And I don't know if I can get in closer. Let me see if I can. Now let me get us up there. Almost looks like they're glued together. You see that? So I'm looking right there. It could be that they're not, but that's really awfully suspicious. Yeah, those guys look like they're bridged. Totally. So how do you fix something like that? I kind of use the brute force method. So let me see if I can do this. I stick the pin in there and I try to break it apart. And I'm doing it completely backwards from what my view is. So, okay, that was a solder ball. Basically, that was a solder ball sitting. And the reason I know it is, see, that's your last pin going in. You can see the circuit board trace right there. That solder ball was sitting there. So I'm actually not sure that that dude was shorting against anybody except for the last pin. So I'm just not sure that that. So what if a solder ball is sitting there unless it was shorting against the ground? I'm not sure it was high enough to do that. Or I don't know if it could short against the side of the chip. I'm not at all sure of that. So definitely a solder ball there, definitely on the power circuit on the chip. These guys, this and this supply the power. Anytime you see capacitors set to ground here, this is the ground plane, I think, and this is the power line. These capacitors remove the noise and then it goes into the chip and feeds the chip and passes through. This is definitely not the clock signal though. So the clock signal, it's close to that, but let's have a look here. Let me see if I want to do this. See if there's anybody else there. So I don't see much of else there. That was definitely a solder ball. Let's see if it was grounding the chip. If it was grounding the power of the chip to the heat sink here, definitely could be a problem. All right, so the last place I'm going to look is chip 1 and 2. See if I can line that up. And I usually use my hand microscope to do this, but it's easier to videotape this way for you. So there's that's coming into chip 1. I haven't put alcohol on it. Sometimes when you do that and clean it up, you see stuff. That's coming into chip 1. That's leaving chip 1. The resistors there are okay. So we're going to leave chip 1 and go through the test ports. So these are the test ports where I stick the needle and test voltages. And a lovely resistor there, and then going into chip 2. And you know, that looks pretty good. And then let's see what's leaving chip 2 here. So if we're leaving chip 2, let me get it down here. So that's leaving chip 2. It looks pretty good too. All right. So I'm suspect to that one where the clock signal didn't go through. And if I switch back videos, let me do that. Bring my video back. Let me swing my camera around. See my soldering iron stuff. So, okay, so that's close enough. All right, so we just visited these chips. I think this is where I found the solder ball leaving this guy or coming into this guy. Very well could have set stuff up going to this chip. I'm sorry for the glare. It's down there, but I should set this up. So the other thing I can do just to check is to check the resistances on these chips. I haven't done that, but I've got them off now. So let's have a look at the resistances, just to see if anybody's misbehaving on the resistance. So let me see how I can do this. I can put this sideways. Hopefully it doesn't glare for you guys. So I'll start with this chip, and I'm just looking for my the one that says about 2.5 and the one that says 10. So this should be my 2.5er. Looks pretty good. That's chip 0, and I think 10 is next to him. 10 is over here. And then these other ones should be straight 0, or else you have a problem with your chip. So, okay, so then I move to this chip and do the same test pins. You can see that. It's really hard to see. So I'm holding it down on the chip and I'm going through the test pins. 0. The input is 2.6. He's a little bit off, but close enough. I've seen it run. 10. 0. So I'm going to go here. I'm going to ground him out. Should be 0. 0. So my 2.5. 2.6 is good. My 10. And a 0. Okay. Let's test out where we found the solder ball. Let's go here. Should be 0. Next test port should be 0. 2.5. 2.6 is good. 10. And then 0. And then 0 here. 0 there. 2.5. 0. I mean 10, sorry. And 0. Okay, let me check this chip's resistance. I'll put it here and then go through these again. 0. 0. 2.5. Okay. 10. 9.99. And 0. Those look good. And then the last one I'm going to do, let's check these guys out. I'll start over here and go this way. Him to the center of the screen. Sorry. Let's try that. Okay, so should be 0 here. Yeah, we get something. Something's wrong there. It means I've got a short. There's my 10 guy. My 2.5 guy. 2.6. Should be, the other two should be 0. Okay. Come back around, do the same thing, leaving the chip. 0. 10. 2.6. 0. 0. Move over here, should stay 0. This guy looks like he's, I tried putting some solder paste on there. 0. 2.6. 10. And 0. I've had various problems on this beginning one, but 0. 0. 2.6. 0. 0. Okay. So at this point, I might rebuild this card and go check, see if that solder ball, at least I'm on the wrong. Go check to see if this solder ball had affected anything. So I'm going to go ahead and put the heat sinks back on here, and I'll end the video, and then I'll put a note, gee, did that fix it? If that didn't fix it, it looks like I've done something with this chip here. I might have replaced it. Let me look at it closer. Could be that I got a bad replacement. In my early days of soldering chips, I didn't clean off the surface as well as I could have with the solder wick. And I'm going to go through doing chips, but it could be, I might have to look at this chip some more, and I'll cue him up to do chip replacement. Although they're reading good, and the voltages are going good. The other hidden place that's not really publicized is, do you remember that solder ball over here that was coming in from these capacitors that's actually a power system? You can test the resistance of some of these guys. See, this set of capacitors right here feed the chip power, and you can actually test the resistance of, I think on that side to this side. It's usually quite high, like 72. And this guy, I think, reads 1.5 if I'm not right, if I remember right. 72 for both. So sometimes if there's something wrong with the voltage regulator down there, you might get a different voltage. Let me see if there's one over here. Here's some right here off this first one. He's 124. He's pretty high, but I think that's still pretty good. It's actually double that. Let me see what these guys are reading. I usually hit it in the 70s. That's 63. 63. So I might suspect him because this power supply. This is the way I found after I do chips. I check the test ports for those resistances, and then actually you can check out the power supply. That's pretty high. And I'll go over where that power supply is. I did a lot of testing and I've replaced those chips before, but probably unnecessarily. 124 is not 60, so that's got the double the resistance on that. So that's another suspected thing. So this is kind of a hard one to solve, because where do you work? It says 0, but yet everybody seems okay. So I just look for other obvious things. Might even have to take off all these guys to do this, but definitely there was a solder ball there. I just don't think it was shorting against anything important. I wish it was in between legs and I could say, hey, I fixed this board, but I'm going to go back to this because it looks like I worked here in my early days learning how to solder, so I suspect that. With that, I'm going to end this video and show you how to put these heat sinks back on. I've seen several people do this. I've resolved to use some of this Chip Quick SMD 291. And just to help me put these back on, I'm going to do this bottom one first. I just put, I mean, like a little drop of flux on there. So what I do is I start my hot air up, 350 degrees. I've got some really nice pair of tweezers here. Make sure your bottom's clean for the most part. So I pick these. So I kind of line them up for me. So I need that one, and I need this one over here sticking. So I'm going to do this one next first. So basically I sit here and I heat these dudes up. And I haven't had, let me get on the video. I just sit there and I run the hot air over these guys until they kind of start to smoke. Somebody said count to 20. I think it needs more than that. I think I was doing 20 seconds before, and it didn't quite settle in, and they would fall off. So I actually put some flux down there so they get hot enough and melt and settle in. And there's a knack to getting them lined up and nice. You don't want to cover up the test ports. And you got to keep a pretty firm grip on these. So these are not the ones with glue. These are actual soldered heat sinks. Okay, you probably can't see it, but it's smoking. So I think I can just drop that guy on there. Sometimes I just throw a little heat on the side to make them settle in, and I think he is. These big guys take a little bit longer. So after I get this board put together, I'll let it cool off a little bit. I've got a big fan running on my miners out there, so I'll put this in front of the fan. After a while, I'll let the initial cool down happen, and then I'll run it through the tester and see if that solder ball changed anything. Probably not. Just telling you, I'm probably gonna have to come back to that chip, which is in number 0. I think it had some problems on the resistance on that initial power circuit. So I think I found my culprit, but let's try this out. And I'll report back on this video when these are in. So this takes a little while. When you do a whole board, it gets kind of tiring actually, because it's just a lot of work to take all the heat sinks off, try to put them back in a line. You don't want to cover up the test ports. So, all right, I'm getting a little smoke out of this guy, so let's set him down there. Probably push them in. You have a second that you can kind of align them. The more you push them, the more chance you have of throwing a solder ball down there. Just make sure he's still kind of hot. Okay, let's come on down here. Just put a little drop. Flux, just a little bit, tiny bit. So we've got a medium guy here. Make sure you guys can see. Heat him up. I get them hot enough to melt the solder on the top of the chip. If you don't, they're not going to stick good. I suppose you can heat them up so hot that they melt the chip solder, but not usually. There's big heat sinks on the back of this that really do the majority of the heavy lifting and cooling. So let's drop that guy in there. Not exactly lined up. I found that when I try touching them again, it's even worse. So, all right, here's a small guy. I'm not such a perfectionist that they have to be perfectly lined up. I try to do my best, and it's really hard when I'm doing a video and I'm kind of at an angle, so I'm just going to let those be. They'll do their job for sure. And just get them nice and warm. They usually start smoking. There's some dust on them or something. You'll see it. And these guys are the hardest because if you go back and touch them, they just jump. You know, down this row are test ports, so you don't want to cover those up because you might have to stick a needle in there. All right, let me get some more flux on these guys. My problem guy, which is chip number 30. I'm going to have to mark this board to look out for chip 30. Let's go backwards on these guys. Usually solder on a big piece of aluminum too, so. If you think you've heated one of these heat sinks up, you get it on there, it melts on, you see it set, then blow on it and start cooling it down immediately, and we'll stop it from getting down below into the chip solder. But usually not. Boy, I'm holding this guy tight and it's still slipping out of my hands. These things are kind of hard with these tweezers. Getting kind of warm. Okay, he's starting to smoke, so I think I'm burning some stuff off, so he's probably warm enough, so I'm going to set him in there. A little toward the testing thing, so I'll move him back just a touch. Unless I keep the heat on. There, that should probably be good. All right, last one. Tweezers stick if you pull on them too much. So. Just going to do a short video for people that need to learn how to take their heat sinks off it. I was really scared to do it, and I pulled a chip out once. I practiced on an S9 board, so I pulled out a chip and said, well, that's not going to work. And a little too yanking on them a little too hard. It's just important to wait till the solder melts and they come right off. Try to lift them straight up. So I kind of feed it down the middle at an angle. So he's smoking right now. He's probably warm enough. So let's set that guy in. Okay. What I do before I go out there, in case I have any bad takes. Let's see if I can get the whole card in the video. For that guy's, he's not cooled off yet. These guys are cooled off. And you can kind of gently do this. That guy's in there. A little light on him. He's still cooling off, but he's in there now. So anyway, that's my research on this card. I will post a video on what happened with this card if I fixed it. If I didn't fix it, we're going to come back around and I'm going to go to chip 30. And we're probably going to pay more attention to that. The way I remove chips is I take kind of whole area out with the heat sinks. I have to remove the bottom heat sink so it heats up. And we may do this chip. That would make sense, 0 coming in, but I'm just not sure. Maybe it was Mr. Solderball here on the clock signal. So, all right. Thank you very much for watching. Again, if you like this video, hit subscribe. It helps you kind of think about your boards and really dealing with your real assets in the miner, which are these hash boards. Feel free to help me out down there, and not going to get rich off this, but any help is appreciated. And thank you very much.